This video is closely related with the previous one. Here we're looking at how AI guesses the next word. We already learned in the last video the computation, the kind of calculation that takes place each time you prompt ChatGPT, for instance. So I will discover that it is actually next token prediction or next token probability prediction, if you like. So here, this still fits into that whole idea. So here we see how AI guesses the next word. So, the learning objectives are as follows. After completing this lesson, you should be able to explain how AI predicts the next word, which we have an idea of already based on the last video and so even videos before that, then define it. You'll be able to define what a token is, explain probability distributions. I mean, we've been saying tokens. I've also defined it a couple of times too. But again, we have another opportunity to learn in clear terms what tokens are. You also want to explain probability distributions, explain token ranking, perform simple next token probability calculations, and simulate next word prediction using Python. So then we describe how autocomplete and language models work. I mean, we have autocomplete on phone, on computer, and everything. So you start typing, and then you see because you're used to your phone is used to the kind of things you say. So, for instance, each time I want to write my name, once I start with my first name, if I want to start typing EMM, it automatically gives me the rest of Emmanuel and even the rest of my name. So that is actually autocomplete, or that's the idea of predictive text. Then we have in the introduction that whenever you type on your smartphone or ask an AI assistant a question, the system must decide what word should come next. For example, the sky is, you already see options like blue, clear, or cloudy. So most humans would naturally think of words like blue, clear, cloudy. The modern AI works in a similar way, but instead of relying on intuition, I mean, the AI doesn't understand the language you're speaking, but it understands the numbers your language is translated to, and then it replies you based on those numbers, and then you see your own words. So it's like we have found a very smart way of communicating with computers. We understand words, computers understand numbers, and then we have found a very nice way of interacting based on our words and computers numbers. So modern AI works in a similar way, like I said, but instead of relying on intuition, it calculates the probability of every possible next token and chooses one according to those probabilities. So AI does not know the future word, of course. Instead, it estimates this. Given everything I have read so far, which next token is most likely? And that is why tokens are assigned numbers. So this process is called next token prediction, like I said previously, and it is the foundation of modern language models. And that is exactly how AI guesses the next word. So it might sound repetitive, but it is very important for to drive the point home. And then get to learn some new concepts that we didn't see in the last video. Now, first of all, I mean, I think this one of the very early videos, say second or third video. So we saw that ChatGPT is just simply a probability machine, right? So this is a reiteration of the idea that AI is a probability machine. So let's see AI as a probability machine. Imagine an AI has learned from billions of sentences. When it receives the input, the cat sat on the whatever. So it considers many continuations like the cat sat on the mat with probability 0.55, the cat sat on the floor, probability 0.1, the cat sat on the chair, probability 0.1, the cat sat on the sofa, probability 0.08, the cat sat on the table with probability 0.07. So the AI assigns the probability to every possible token. So thankfully, you don't have to assign manually. The model, whatever language model you're using, automatically assigns the probability, the token, the probabilities like that. So notice that all probabilities always sum up to one. Of course, that's an essential nature property of probabilities. First of all, probabilities are they are not less than zero, and the probabilities always lie between from 0 to 1. It can be anything from 0 to 1, not less than zero, not bigger than one. And then, of course, every probability in a distribution must add up to one. So usually, the token with the highest probability is selected, although other selection methods are also possible. In the last video, we saw the idea of greedy decoding. That means you automatically just pick the token with the highest probability. But there are other sampling methods that we also learned in the last video. Now, the question again, what is a token, right? First of all, a language model predicts tokens, not necessarily whole words. So a token is simply a small unit of text. So it can be you have one word broken down into several texts, or a sentence broken down into words. So for example, the sentence I love programming may be split into the following tokens. It can be split into I, then the space and love, I, space and love, space and programming. So I love programming, and then even the full stop is also a token. So some long words are split into multiple tokens. So if you have long words, like even a word like programming can be split into program and ming, whatever. So for example, if you have internationalization, so it might become international and ization. Therefore, language models actually perform next token prediction, not strictly next word prediction, because uh AI doesn't understand words, they understand numbers, they understand tokens. In fact, they don't directly understand tokens, they understand the numbers assigned to tokens, basically. So AI guesses the next word through a process called next token prediction, right? So then we have the prediction process itself now. Suppose the input sentence is, I drank a cup of whatever. So the AI evaluates many possible next tokens. Say tea at with probability 0.4 to coffee 0.35, water 0.10, milk 0.06, juice 0.04, soup 0.03. So these probabilities form a probability distribution, meaning that none of them should be less than zero or bigger than one. And then if you add up all of them, they should add up to one. So the AI then ranks these tokens and selects one according to a decoding strategy. So whatever decoding strategy you're using, if it is greedy, AI just picks the highest of the one with the highest probability. Then there are other processes like random sampling or top K sampling or top P sampling and all of that with a given probability. So now we go on to talk about probability distribution. A probability distribution assigns a probability distribution assigns a probability to every possible next token. Okay, I think this should properly be put into maths form with this in dollar signs now. Come here now to token, dollar, and then dollar. Okay, so here now, a probability distribution assigns probability to every possible next token. Mathematically, probability of a token I P of token I, where P denotes probability, token I is one possible next token. All probabilities must satisfy the fact that the sum of all probabilities across all tokens must be one, just like we said the other time. So this means that the total probability across all possible next tokens always equals one, or simply is 100%. So then we have an example of a probability distribution. So suppose the AI predict the following probability. Say apple is 0.40, banana is 0.25, orange is 0.20, mango is 0.10, and pear is 0.5. The probabilities sum up to 1. If you add it all up, you have 1. This represents a complete probability distribution over the possible next tokens. Like that. And then you can visualize the distribution. Apple at 40%, it's more like you have this very long bar, banana 25%, not as long, orange 20%, not as long as 25, mango 10%, not as long as orange, and pear 5%. And then the tallest bar corresponds to the most probable prediction. And if you're using greedy decoding, it automatically pick apple like that. So uh, then we have token ranking, right? So talking about token ranking, once probabilities have been computed, the AI sorts every possible token from the highest probability to the lowest probability. So this ordering is called the token ranking. So if it is not ordered, you have to order it from the highest to the smallest. So for example, input, the capital of France is blah blah. So Paris 0.95, Lyon 0.02, Marseille 0.01, London 0.01, Berlin 0.01. Now, since Paris has the highest probability, it becomes the next predicted token if you are going by greedy decoding, where you just pick the token with the highest probability. So so let's take some examples. Impute the sentence, the dog chased the so imagine you input the sentence, the dog chased then the predicted probabilities for cats, ball, rabbit, and squirrel will be 0.6, 0.2, 0.21, 0.08. So step one now, you rank the tokens. First of all, the cat has the highest probability, followed by ball, followed by rabbit, followed by squirrel. Squirrel. If it wasn't arranged, you have to arrange yourself. Then in step two, now you choose the highest probability. So the highest probability, since 0.6 is greater than 0.20, greater than 0.12, greater than 0.08, the AI predicts that the dog chased the cat. All right. The dog could actually chase the ball or rabbit or squirrel, but based on the model from which this, based on the database this AI model has learned from, cat comes tops like that. Then example two, if you improve the sentence, she opened of course, she can open the door, the window, the box, or the letter. But based on the model on which this, let's assume based on the model on which a particular model is trained, the door is probability 0.45, window is 0.25, box is 0.18, letter is 0.12. And that is why AI can make mistakes, because if it is trained on another kind of database or so, you know, uh, window may rank higher, right? Because she can open any of these things. So the highest probability here though belongs to door. So therefore the prediction becomes she opened the door like that. So now the real reason why we're here is how AI guesses the next word. So now, how does it go about choosing the next token? So the simplest prediction strategy, like I've been talking about it, is called greedy decoding. The algorithm is compute probabilities, rank all possible tokens, select the token with the highest probability, then append or add the selected token to the sentence, and repeat until the sentence is complete. So that is the process of how AI guesses the next word. So imagine I like pizza because it is delicious. So like you have once you type I like, then it gives you words pizza, bread, everything. But pizza has the highest probability. So it chooses pizza. Then next tells you because from then because wins. So yeah, I like pizza because it is delicious. And that's how everything is predicted. So and that's why you have the words coming out sequentially, because you have fast succession of probability calculations and choices being made based on the tokens with the highest probabilities at each step. So talking about random sampling now, which we also considered in the last video. So instead of always choosing the most probable token, AI may randomly sample according to the probability distribution, right? So sometimes the word with the highest probability may not be the correct one, right? And that is why there are other sampling methods. So for instance, you have happy 0.5, excited 0.3, thrilled 0.2. Although happy is most likely, the AI may occasionally generate excited or thrilled. So, and that is why when you prompt AI, the same prompt, if you feed the same prompt to the same model 10 times, there's every likelihood, of course, you may get the answers in context may be the same, but the set of words will not exactly be the same, because if it's always following the greedy decoding, if you prompt it 1,000 times, you always get the same sentences and everything. And that is where random sampling comes in. So random sampling brings a bit of variety into the whole situation. So sampling makes generated text more diverse and creative instead of making it monotonous, always giving you the same set of words. Now, let's look at an application, this application now in autocomplete. Autocomplete systems on smartphones and search engines use next token prediction. Suppose you type see you blah blah. So say see you tomorrow with probability 0.55, see you soon 0.20, see you later 0.1, see you then 0.07. All these are possible things in English language, right? These are possible suggestions, but based on whatever this model is trained on, tomorrow comes tops with 0.55. So the highest ranked suggestions are displayed first. That's tomorrow, soon, and all that. So, and the benefits include, of course, faster typing, fewer keystrokes. So in that case, instead of having to type everything, you can just pick the words you wanted to type, or the word that you were thinking to type, because you already have them suggested to you. So the benefits include faster typing, fewer keystrokes, context-aware suggestions, improved writing efficiency. Okay, so that's one example for application in autocomplete. How about application in language models, which like ChatGPT and all of this, Grok. So application in language models. Modern language models generate text by repeatedly predicting one token at a time, right? So the process is read the current context, you understand the current context, then you compute scores for every token in the vocabulary. That is the AI is doing all of that. The language model is doing that. It reads the current context and computes scores for every token in the vocabulary, then convert the scores into probabilities, ranks the tokens, select one token, append it to the sentence, and repeat it until the response is complete. That is why generative AI produces answers sequentially, not outputting the words all at once. So they come step by step because a lot of probability calculations are going on and a lot of decisions are being made from time to I mean every step. So although these models appear to understand language, they fundamentally generate text through repeated next token prediction. So I've said it for the umpteenth time that AI models do not understand human language. Human language is about words, computer language is about numbers. So the whole thing we are doing is converting human language to computer language through processes like tokenization, embeddings, and all of those things that I've been explaining all along. So in summary, the key ideas are as follows. You have a token, which can be seen to be the smallest unit of text predicted by the model, by any given model. Then you have probability distribution, which is probabilities assigned to every possible next token. Then, if you have 10 tokens, you have probabilities assigned to them, and all these probabilities must add up to one. If you have 1,000, you have probabilities assigned to them, and all these probabilities must amount to one. And then you can now use the strategy to choose the best word. Then token ranking, now ordering tokens from highest probability to lowest. And you have greedy decoding, always choosing the highest probability token. Sampling is choosing tokens randomly according to probabilities. Autocomplete predicts likely next words while typing. And language model generates text one token at a time. So key takeaways from all of this is that AI predicts the next token, not necessarily the next whole word, because AI doesn't understand words. Then every possible next token receives a probability. These probabilities form a probability distribution whose total equals one. Then tokens are ranked from the highest probability to the lowest probability. The selected token is appended to the sentence, and the prediction process repeats, and that is how AI guesses the next word. Then this simple prediction loop powers autocomplete systems and modern large language models, modern LLMs, if you like. So we have our practice problems as usual, and of course, like it goes, get a solve two of them. Here I'm solving 6 and 19. So look at the problems here. Um, Here I think you should be able to see one to three. Explain why language models predict tokens instead of complete words. Said it. You know, because computers do not understand human language. So when you prompt an AI, your sentence or whatever you have put in is broken down into they are split up into bits and pieces of words like that, chunks of text like that, and then they assign probabilities and all of that, and then that way we're able to communicate. So questions one to three here, and you have questions four and five, question four and five, and then you have question six to say I guess you can see 6 to 10 here. So I'll be dealing with question six. Suppose the vocabulary contains 50,000 possible tokens. Does the language model probability does the language model assign probabilities to only the top five tokens or to all 50,000 tokens? Explain your answer. So we're going to deal with that. Then you have all this up to 10 now. So, of course, difference between greedy decoding and random sampling. Greedy decoding, you always pick the word with the highest probability. Random sampling, because of variety and creativity, you want to pick, you don't only get to pick the token with the highest probability next, right? Then we have 11 to I mean, you can see 11 to 14, you can see 11 to 15 completely here. 11 to 15 can be seen completely here. And then we have, okay, let me show 11 to 15 again. All right. And finally, we have 16 to the end. So I'll be solving 19 again. Describe the sequence of steps a language model performs after receiving an input prompt until it produces the next token. So let's go for this as we begin to bring this home gradually. So let's go for problem six, I believe. First of all, problem six. So we have problem six. Suppose, suppose a vocabulary contains 50,000 tokens 50,000 possible tokens. Possible tokens. Thus, does the language model assign probabilities to only the top 5 tokens or to all 50,000 tokens? Explain your answer. Explain your answer. Okay, so the answer, we know that a language model assigns a probability to every token, to every token in its vocabulary, every token, all the 50,000, every token in its vocabulary, vocabulary, not not just the top 5, not just the top 5. Okay, so that's settled. So next thing is that if the vocabulary contains 50,000 tokens, 50,000 tokens, then the model the model computes a probability for each of the 50,000 possible next tokens. So after assigning probabilities, it ranks it ranks all tokens from the highest probability to the lowest probability. Usually, usually only the highest ranked, only the highest ranked tokens are shown to users or considered considered during text generation. So I mean, so even in using your phone, right? Those 3 or 5 suggestions you are seeing, those are not all, but those are they are the highest ranked. So are shown to users or considered during text generation. Text generation. But but the probability distribution, but the probability distribution distribution itself includes every token, every token in the vocabulary, in the vocabulary. So final answer, the language model assigns, language model assigns probabilities to all 50,000 tokens, then ranks them, before selecting the next token. So that goes, and we move on to problem 19. So it says describe the sequence, of steps a language model performs after receiving an input prompt until it produces the next token. Okay, straight up solution. So of course the language model performs the following steps. So first of all, read the input prompt. So to read the input prompt to get the current context, That's one. Number two, it will convert the inputs into tokens. Then three, it will analyze the relationships among the tokens using the trained neural network, Okay. Number four now. Then it will compute a score for every possible token in the vocabulary. Number five, it will convert the scores into probabilities so that all probabilities sum to 1. Then six, it will rank the tokens from the highest probability to the lowest probability. Then seven, it will then select the next token. Select the next token using a decoding method or strategy, such as greedy, greedy decoding, or random sampling, or random sampling. And 8, to append the selected token, append the selected token to the existing text, to the existing text. 9, repeat the entire process, repeat the entire process until the response is complete, until the response is complete. So we have this kind of flow diagram. Flow diagram. So you have input prompt. So you write your prompt. Then next, that goes to tokenization. So the prompt is broken down into tokens. We have tokenization. Then next, we have neural network processing. Neural network processing. Then afterwards, you have probability distribution. Probability distribution. So the neural network processes can be anything from the whole using vectors or then leading to assigning of probabilities and everything. So until I mean, the whole, talking about the process that leads us to up to softmax to then get the probability distribution. So in the last video, I think we saw the idea of, I'm trying to remember the word now. Hmm. Is it logits? Yeah, logits that then become probability later. So you have probability distribution. Then next, after probability distribution, you have token ranking based on probability now. So you rank the tokens based on the probability. So you have token ranking. Then afterwards, you have, because based on the ranking, you can now do the token selection. Of course, based on the method you have chosen, be it greedy or random uh, method. Then the next thing is you can then append the token, append token, append the token, and then you can repeat. Then you repeat. So this is what the flow diagram looks like. So this is what everything looks like in a blow. So input your prompt. The prompt is tokenized. Neural network processing takes place. Then you have a probability distribution. Then the token ranking, token selection. Then the token is appended, and then you repeat, rinse and repeat if you like. So yeah, that's how that goes. So finally, right? Um, this repeated, this repeated prediction, this repeated prediction of one token one token at a time is how modern modern language models modern language models generate complete sentences, complete sentences, paragraphs, and conversations and conversations. And that is what we have. So with this, we come to the end of this interesting video, and we see how AI guesses the next word. So again, I flash the problems. So yeah, here you have problems 1 to 3 clearly displayed. 1 to 3, then 4. Okay, you can see 4 to 6 here. Then 7 to 10. then 11 to 14, 15 to the end. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed to the channel already, I thank you very much for doing that. If you have not, why not go ahead right now, hit the notification bell, subscribe, of course, and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of this channel by clicking on join. That gives you some special privileges you find out when you click. Ultimately, don't forget to comment, like, share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.